Hey everyone. In this video, we're going to be having a look at logarithms, sort of a bit what they are and how they work and how we can sort of simplify different things. Firstly, what is a logarithm? Um, so probably the easiest way to explain it is I can just tell you that the logarithm is just what the power is. Okay, so you're just looking at what the power is. But just as a sort of a brief overview, when you've got exponential functions, and so an exponential function will look like that. All right, so an exponential function multiplies by its current value at any one time. So if you think about what the y value is at any given time, then that y value gets multiplied by an additional 10% or something like that. It increases by 10%, and then that y value increases by 10%, and then that y value increases by 10%. And you see, as what the y value increases, then the amount that it increases, if you know what I mean. And that's what we call exponential growth. And so that difference between one y value to the next y value, I haven't drawn it very well there, but you sort of get what I mean, sort of thing, that that difference between there and there is growing all the time. It's growing exponentially. It's getting bigger and bigger and bigger, and it's growing faster and faster and faster. And this happens in nature all the time. Populations increase like this. Animals breeding and that sort of thing grows like that. Viruses grow like that. COVID grew like that. Has this exponential growth that goes on. And when you're getting numbers that get bigger and bigger and bigger like that, it's actually hard to keep track of those numbers and to compare one number from one to the next because the numbers are getting bigger. And so what you end up with, if we write these things in scientific notation, like you might have 3 times 10 to the power 3, and then might after that you might get 4.2 times 10 to the power 4. And then 5.6 times 10 to the power 5, and what happens is that it's actually easier to keep track of the powers rather than keeping track of like the whole number within itself. And so if we just consider the powers, then the graph of it actually becomes linear. And so it's easier to sort of watch what's happening between the powers to give you an idea of the magnitude of the number rather than the whole physical number. I hope that sort of makes sense a little bit. So the reason that logarithms were invented was to like actually watch the powers, to keep track of the powers, the exponents, to try to see what's happening there. And so basically, what a log does is the log asks you what is the power of something. Okay, so if I had log 2 of 8, what that means is it means 2, I'm not going to write equals because I don't know, but what it's asking you and what the equivalent is 2 to the what, that's a question mark, is equal to 8. It's asking you what power. So 2 is the base, 8 is the answer or the numeral that it will be equivalent to. And so you need to figure out what the power is. So 2 to the power what is equal to 8? 2 to the power 3 is equal to 8. And so that means log of base 2 of 8 is equal to 3. And so if I just erase that question mark and put in a 3 in there, then these two statements are equivalent to each other. So log 2 base 8 equals 3 means the same thing as 2 to the power of 3 is equal to 8. 2 is the base. 2 to the power of 3 is equal to 8. And so you'll see that that's the base in there. That's let's call it the answer. All right, there's the answer there. And that is the power. And so the log is giving you the power of the situation. Okay, so that's pretty much how they work. Just a couple of things that you might see. I'll just sort of get rid of some of this, give myself a bit of space. The different things you might see is sometimes on the calculator you might just see the log button, right? And it doesn't have any base on it or anything like that. And so if you have a log button, it has no base in it, then the calculator is assuming that it's base 10, right? So if you do log base 10 of 100, that'll be equal to 2, right? Because 10 to the power of 2 is equal to 100. And if you just type into the calculator log 100, the calculator assumes that it is base 10, and so that it will just say that it's 2. The other thing to be aware of is you'll also see the ln button on your calculator. And what that means is that means the natural log of 2. And what that means is log base e of 2. Okay, e is Euler's number. Euler's number, which is, roughly 2.718 something. And that's the base of natural growth. And so if we get this natural growth that comes up a lot in nature, comes a lot in finance and big economics and that sort of thing, then you get this exponential growth of about that. And so we'll talk about that later when we get to exponents, just so that you know, if you see ln, that means natural log, which is e is your base. But if you see a log without any base, that means log 10. All right, so let's get into some specifics. So let's have a look at some laws here. So our laws are as following, and these just follow from our index laws that we've had previously. And let's have a look at them. So if you've got log base a of m plus log base a of n, what we can do is we can put those two things together. We can put that together, and we put it together with still a as the base, but with mn. So we can put those two things together. Similarly, if we subtract two logs with the same base, then we divide the m and the n to get that result there. If you have log base a of something with a power in it, so we've got this sort of n as a power, then you can actually pull that power out and it sort of goes down to the front and it becomes n. You can bring that out. That's a really useful property that like whenever you're stuck doing a log question, then often that property will help sort of get you out of jail. So just keep that one in mind. This one just makes sense because a to the power of 0, so anything to the power of 0 is equal to 1, and so that's where that result comes from. And also, if a is to the power of 1 is equal to a, and so we get that result there. So those two are sort of used quite often, but make sense just coming from powers. There's no such thing as log a0, because if you think about it, if you got a to the some power is equal to 0, that is not possible. Okay, you can't find a power where you raise a number to another power and to get the answer of 0. So that is undefined. And finally, the last sort of thing here is that if you raise a to the power of log base am, they're sort of like the inverse of each other. Well, they are the inverse of each other because log is asking what is the power, and if you raise that from a to the power of that, if it makes sense, it just undoes everything and you end up just with m. Just like if you square root of x squared, you'll just end up with x. So it's just undoing the previous function. And I hope that makes sense. I'm just going to clean all that on my writing up, and then let's go to a couple of examples because you need to know how to apply these to certain numbers. So let's have a look at that now. So here we go. So we've got, firstly, log base 3 of 3, take away log base 3 of 27, plus log 10 of 1000. So let's go and simplify this now. So firstly, log 3, that was one of our laws before. 3 to the power of what is equal to 3? Well, that is equal to 1. Okay, that first one, that is equal to 1. 3 to the power of 1 is equal to 3. Next, we have log base 3 of 27. Well, 3 to the power of 3 is 27. So that second one, that there, will be minus 3. And then lastly, we've got log base 10 of 1000. So it's asking you 10 to the power of what is equal to 1000? 10 to the power of 3 is equal to 1000. So my answer, 1 take away 3 plus 3 is just going to be equal to 1. And so as long as you know your powers fairly well, you'll find questions like that to be not too much of a problem. Okay, let's have a look at this second one here. We've got log base 2 of 24, take away log base 2 of 3. Okay, so in this one, you'll look at that and you go, well, 2 to the power of what? 2 to the power of what is equal to 24? And then you go, I don't know, because it's not a clean one, because 2 to the power 4 is 16, 2 to the power 5 is 32, so what is it? And so this is one of them where you have to go, well, I actually need to do something different here. You'll notice that because they're both log base 2, we can put these two things together. Okay, so if they have the same base, then we can put them together. And what will it be? Up here, we saw that if we've got subtraction of logs with the same base, then you can just divide the middle of the log, the inside of the log if you get. So what this will end up being is that'll be 24 over 3. So that can just go together in that. And now it looks a bit nicer because all of a sudden that's log base 2 of 8. That's nice. We know that 2 to the power of 3 is equal to 8, so that log is just equal to 3. No problems whatsoever. Next one, let's have a look at this guy. Again, this is something that we can't actually deal with at the moment. We don't know 10 to the power of what is equal to 5. I don't know. I really couldn't tell you. 10 to the power of what is equal to 4. Again, we don't know. So we need to actually do a bit of work with this and think about what we can do to simplify. We can't actually add them at the moment either. We can't add them because there's this pesky little 2 out the front here, and that's not part of any of our log properties, okay? I'm not allowed to add these together yet because in here there's I can't have a number out the front of one of the logs. So we need to do something with that too. So that's a little clue as to what we need to do here. So let's first have a look at what can we do with that 2 there. I'm just going to get rid of my scribbles a little bit because that doesn't help. So let's have a think about what we can do. Well, the third log law here says that if we have a power here, then that can go out the front. That can be moved out to the front of the log, and vice versa. If we've got something out the front of the log, then we can move that up into a power. So those two things we can do. That helps us play around with some of our logs here. So what we can do is this is equal to, so I'm going to get that 2, and I'm going to move that up as a power of the 5. So that's going to be equal to log base 10 of 5 squared. So that comes up the top as a power, and that'll be plus log base 10 of 4. Great. Now that we've got just a normal log plus a normal log with the same base, we can now multiply those two answers together. So let's do that. So it'll be log 10. 5 squared is 25 times by 4. And again, it starts to look very nice here. And hopefully most of the time it will come out nice. 25 times 4 is 100. And that is equal to 2 because 10 squared is equal to 100. And so 2 is my answer there. Hope that makes sense. Last example, let's have a look at this guy here. Now we've got log base e. So there's our natural log there, okay? Our natural log. Let's have a look at what we can do. At the moment, we could put those two things together. So we could and sorry, I just need to sort of also say, because I almost did it myself, it's really tempting to think about this like indices and that sort of thing, to go, well, we're dividing here, so we subtract the numbers or something like that. And just remember, in our log laws, there's no such thing as timesing or dividing logs. We can't simplify those easily. And so here in this situation here, we can't do anything. There's no log law at the moment that will help us here. But there is still some things that we can do. And so let's have a look at that. So don't jump to any timesing or dividing logs. There's no quick answer to it. Okay. So what I'm going to do is just do a bit of simplification. I can see that there's 16 and 8 here, which are both powers of 2. So I'm going to sort of do a couple of things. So let's go log base e. And 16 is 2 to the power of 4. I always do this one. All right, so that's 2 to the power of 4, like that. Okay, and on the bottom line, I'm going to go log e of 2 to the power of 3. Okay, does that help me? Well, remember, I can do something with the powers out here. Okay, I can sort of do some little tricky magic with that particular rule. Remember, that rule says I can bring the 4 out the front of that log, and at the bottom line I can bring that 3 out the front of the log. Okay, so on the top line it's going to be 3 times 4 log e2. That's what's on the top line, because I've brought that 4 down to the front. Okay, so it'll be 3 times 4 log e2, and on the bottom it's going to be 3 times log e2 on the bottom line. Okay, now that looks good because I've got log e2 on the top line, log e2 on the bottom line, so they just cancel out, and I get an answer. Well, the 3 and the 4 will also cancel out, so that's just equal to 4. Okay, so that sort of pulled out really nicely. And so that's sort of a couple of ways that we can deal with logs using our powers. Hope that all made sense. I'll see you in the next video.